Right, so today we are going to talk about geometry. Now, suppose I give you two pieces of a cake and consists of many squares. Okay, so square type of a cakes, put together. Okay, there are two different shapes. Okay, and I, my question is. My question is, which ones have more squares? Okay, well, you just look at both sides. You find out if you view this one, the first one, right? And there was two rows. In each row, there was there are six squares there. So 2 rows, 6 squares, right? Then the number of the squares is going to be 2 times 6, which is 12, right? Then here, each row, they only have 4 squares. Okay, there are 4 squares. Okay, but then there's 3 rows there. So total will be 3 times 4 is 12 square there. Okay, so that means they're the same. So then you can say there's no difference, only they look different. But that each one contains exactly 12 squares. So this 12 really tells you the number of the squares inside, right? So this is going to be, that's what I have to say. What is 2 here? 2 is this side, right? 6 is this side. And this side is 3, that side is 4. Okay, so 3 times 4, 2 times 6. So they both are equal to 12. Then, okay, in order to tell the number of the squares in a rectangle, this is called rectangle, right? And then number of unit squares in the rectangle, and all I have to do is just do the product of the two sides. Okay, given an arbitrary rectangle. Okay, and this side you have a let's call it A. The other side is a B, right? The B means how many units along this side, and A is how many units on this side, right? So the product gives you the total number of squares. For example, if A and B are both integers, then A times B is going to be the product, is going to be the number of the squares, unit squares inside this rectangle. So that is going to be called the area. Okay, so we introduce a new notation. It's called the area. Okay, area really tells if A, B are integers, area tells you the number of unit squares contained in the rectangle. Okay, if A and B, okay, are both integers. Okay, if A and B are both integers, then A times B then the area, okay, which is A times B, is the number of the unit squares inside the rectangle. Okay, if you divide this rectangle into many squares, okay, in the rectangle. Okay, so that's the geometry meaning of the area. Okay, now more generally, A and B are not necessary to be integers. Then that still tells you how many unit squares are contained in the rectangle. Okay, so this is the notion of the area. So now, okay, and another notion for the rectangle is we want to, if you use 4 line segments to include this rectangle, then the so-called pyramid. Okay, this is going to be, there was a 2b here, the 2a here, so and 2a plus 2b, that is the called pyramid of the rectangle. All right, but that does not tell you how many unit squares inside the rectangle, but that tells you how long, for example, it's kind of like a garden, right? Then that tells you how long of the fence around that. Okay, the perimeter, still have a geometric meaning here. Okay, it does not tell you how many unit squares are enclosed, but it tells you the sum of all the edge lengths of this rectangle. Okay, all right. So now let's look at the special case, squares. Squares are special rectangle. Squares means A equals B. The width equals length. Okay, so those are called squares. Okay, so those sides are equal. Okay, then that's called squares. Okay, right. So that's called squares. Squares are special rectangle. Okay, the special rectangle. Now, what we needed to know is, okay, let's compare which one has a larger area. Okay, one is I have this side is 2, that side is 8. Okay, then then I draw the square. Okay, I draw the square, and that square is going to be as this side is a 5. That's a 5 and the 5 and the 5. Okay. Okay. Now let's compare the perimeter. Okay, perimeter both. Okay, the left hand side, the perimeter is 2 times 8 times 2 plus 8 plus 2 plus 8, right? So total is 20. The perimeter on the left hand side, on the right hand side is 5 plus 5 plus 5 plus 5 is also 20. So that means for this two rectangular region, okay, if you want to use a fence, okay, to enclose it, right? And then you need the same length of the fence, right? Clear. Now, what's the difference between them? They both have the same parameters. They have the same parameters, okay? They have the same parameters, okay? Now, clearly they're different, look different, right? Okay, if I give you a 20 feet long fence, and I tell you, hey, please go ahead to make a vegetable garden, right? But this should be a rectangular shape. Now, there are two different versions you can get, right? One is like one side 2, other side 8. Also, another one is a 5, 5. Now, which one contains more area? Okay, so the one on the left side, so the area on the left hand side, okay, the area it's going to be 2 times 8. It's a 16. We call the square units. Okay, just multiply that together. That means if you divide them into unit squares, you have a total 16 unit square there. Okay, the total 16 unit square there. 1, 2, 3, 4, 5, 6, 7, 8. So 16. Okay, total you have 16 unit squares. Okay, but the other one, okay, the one on the left hand side and right hand side is going to be 5 by 5. It's 25. So that means it's much larger on the right hand side. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so that one it's much larger. It's contain 20. That contains 25 unit squares. Although both parameters are equal to 20, they have the same parameter, but one has a larger area. Okay, so this one has a larger area. It contains 25 unit square there. So if I give you the fixed length of the fence, which is 20 feet long, and it's better to make a square vegetable garden instead of rectangle. If you're free, you can make any shape of the rectangles, then you should make a square. Okay, so this one has a 25 unit squares. Okay, it has a 10 and this only has 16 unit squares. Much smaller, but uses the same length. Okay. Okay. So in general, okay, we do have, yeah, in general, we have the following theorem in mathematics, okay, among all the rectangles with the same parameter, square has the largest area, okay, among all rectangles was the same was the same parameter, okay, the square has the largest possible area. But it's not easy to prove, okay? You need if you take my advanced math class, you can prove that, okay? Among it's the largest possible, has the largest possible area, okay? And as long as I have the same length, same parameter, and the square gives you the largest possible area, okay? The square gives you the largest possible area, okay? Okay. So yeah, you can try, you can try to show that, but without looking at any books, okay? But this is not easy to prove, okay? All right, so let's focus on the squares. Squares so nice, right? Let's focus on squares. Look at the square. All right, let's look at the square. All right, square special rectangles, okay? So look at the square. Now that's the important factor here. So you're wondering how long is this diagonal? Okay, let's call it D. Okay, what's the relationship between that? Here's another theorem we may not be able to prove right now unless you learn the Pythagorean theory. Okay, which is we're going to study next class. We're going to prove that in the next class. We have another important theorem. The length of the diagonal of the square is going to be square root of 2 times a. Okay, so that means square root of 2. What is a square root of 2? How big of the number, right? If you look at the calculator, grab 1 point, square root of 2 is the irrational number. It's going to be about 1 point. It's about 1.14. Okay, so this is a special number. Okay, and it's how long the square root of 2. If this side is 1, this side is 1, this side is a square root of 2. Okay, so if you can figure it out, okay, that is square root of 2. We're not starting doing rectangles, but I just tell you this is the length of the diagonal. Okay, so that's the relationship. So let's do some exercise. Okay. Right. So we have a one square and another square. We use the diagonal to make another square. So the two squares here. Okay. So what is the ratio of their areas of these two squares? And the largest square, the edge length is the diagonal of the smaller square. Okay. So the edge of the largest square is the diagonal of the smallest square. Okay, so let's compare the ratio of the areas. Okay, and there are many ways to do that, but let's try. I'll give you 1 minute to think about. Okay. Yes. All right. So anyone has answers? Alex says 1 to 2. Okay. Now we can use the formula to do that. We can all just use a picture to show. Okay. So this is a small square. The other one is a larger square, right? Okay. But you can divide the larger square into extend this line, extend this line. Okay. So you can see that the larger square contains 4 triangles. The smaller square contains 2 triangles. Okay, so the ratio, okay, is going to be 2 times something, right? 2 triangles here, and the bottom one is 4 triangles, right? So 2 over 4, right? So that is going to be 1/2. You can simply say that. Okay, so you have 2 triangles. And the ratio, 2 triangles, the area, if you compare the area, right? And the larger one has 4 triangles, 4 identical triangles. So there should be 2 over 4. It's 1/2. But we can also do the following, okay? So this is A, that's a D. That's a D, right? So the area of the smaller triangle is A squared because A times A, right? The area of the larger square is going to be D squared, okay? But we also know the theorem, D is going to be square root of 2A. So you put it here, okay? So that would be A squared, square root of 2A squared, which is A squared. Now square root of 2, when you square it, it's going to be 2. Okay? So cancel it out, it's going to be 1/2. Okay? Remember, the square root of 2 is a number. When you square it, it's going to be 2. Okay? So what is square root of 2? Oh, some number. It's a square, it's going to be 2. Okay? What is the square root of 3? And that is some number. It's a square, it's going to be 3. Okay? But that is the irrational number. You can only estimate. You cannot give me the exact value square root of 3. You can say in the decimal form, you can only say it's approximately like 1.718 something, right? Anyway, so do you need to know exact size of the smaller square? You don't need it, because when the small square increased, the larger square increased proportionally. Okay, so there, yeah. Okay. All right. Another problem is, yeah. If the square here, this is a square, okay? And if the length of a diagonal, there are 2 diagonals there, okay? A diagonal is going to be 3 square root of 2, okay? Units. What is the area? Okay. And what is the perimeter? Okay. So think about this, right? When you're trying to solve a geometry problem like that, you have to record the formula you have, right? Record the formula. If this side is A, this side is A, and this is a D, right? The formula we have, a D equals square root of 2 times A. Okay, we're going to prove that in the next class, but we use that, for the square. Okay, this is the diagonal, right? All right, and what you are given. So write down the formula first. Okay, this formula. We are given the diameter as the length of the diagonal, which is 3 square root of 2, right? We want to find the what? Find the edge. And the edge, and this is by, D equals square root of 2 times A. So that means square root of 2A should be 3 square root of 2, right? So what do you get? Well, A is going to be 3. So the edge length is 3, right? So then you can get everything. So area is going to be a equals a square. It's a 3 square. It's going to be 9, right? Once you find the age, the perimeter is going to be, how many is there? 4 sides, 4a. So it's a 4 times 3. It's going to be 12. Okay, so that is 12. It's not, well, where is the 32 from? Camera, okay? So if you know the age, okay, and then, yeah, then you get this, right? So let me go back to the square root 2. Square root 2 is a very special number. It's a square is going to be 2, okay? So that means if I have 1 over square root 2, okay, I can do the following. Okay, I can multiply numerator and denominator by both by square root 2. Then square root 2 square is going to be 2. Okay, so 1 over square root 2 can be written as square root 2 over 2. Okay, this is just some number. It's a square is going to be 2. Okay, you know, if I ask you what is square root 2? Well, some number. It's a square, some positive number. It's a square is going to be 2. Okay, and this is a very special number. It's an irrational number. It cannot be written as integer over another integer. It can. Right? All right. We just need this property. It's important property. Okay, some number. Yeah, if it's a square equals 2, then number is a square root 2. Okay. Yeah. All right. So now let's look at the following problem. Okay, I'm given a square. Okay, if this side, so if the length of a diagonal is going to be 2, okay, what is the area? Wow, so d equals 2. Okay, d equals 2. Let's find out the area. Okay. Yeah, let's find out the area. How do we solve this problem? Go. Okay. All right, so you need to find the area, you need to find the A, right? The edge length. Okay. But we do have write down the formula. Equals square root 2 times A. Okay. Using this formula, what we are given? We are given 2, right? And D is equal to, and we don't know what is A. Okay. Good. So from here, how do you solve for A? Well, A is going to be 2 over square root 2. Okay, now can we simplify it? We're trying to simplify it, okay? Rationalize. Okay, so it's going to be 2 over square root 2, and I multiply the numerator by 2 and multiply the number by 2. So you do not change, essentially change the number, because this can be canceled out, okay? Important. Here's important. If A times B over C times B, then that's going to be A over B, A over C. The B will be canceled if they're both B are the common factor. Okay, so that's why you can multiply 2 by square root 2 by 2. Then you what? Then the numerator get 2 times square root 2. The denominator is a square root 2 square, right? Which is going to be 2. So now I have a 2 canceled out. It's just a square root 2. Okay. Okay, A is a square root 2. Okay, now you have something. Square root 2, square root 2. Okay. So what is the area? So the area is going to be square root 2 square. Okay, this is again, it's 2. Okay, so if the length of diagonal is 2, then the area is going to be 2. Sounds pretty, yeah, they have different units. One has a square unit, right? And the other one is just the, unit. Okay. All right. All right, let's try another problem. Okay, so let's look at the area of the following one. Okay, I have a rectangle. Okay, I have a rectangle. Okay, and I know this time let's leave it special. Okay, so I have this side, one side I have a 3 feet. Okay, other side is 4 feet long. Okay, all right. So what I'm going to do is I'm going to add an H on all the sides. Okay, the width of the H is going to be half of the feet, half of the feet, half of the feet, half of feet. Okay, so my question is, what is the area of the we call the sidewalk? Okay. Okay. How do you find this area of sidewalk? Okay. Clear, right? So we know the inner rectangle. This is the inner rectangle. We are given this. We are given the length, yeah, and the width. Okay. So we are given this inner rectangle. We are given this, and this side is 3 feet. This side is 4 feet. Okay. And I want to find the area of the sidewalk. Okay, can you use can you figure it out? Okay. Okay, there's two different ways to solve the problem. One is a direct way, just to look at decompose the sidewalk into many I'm going to show you two different ways. Okay, and you will see some ways takes more time than other. Okay, so right, sidewalk. So what I'm going to do is I divide them into squares and rectangles. Okay, so the two little squares. Okay, the two little square and 4 little squares, 4 corners. That's 4 square here. Okay, this is 3, right? That's 1/2. So that's a 3. That's a 4. That's a 4, right? 4. So it's 1/2. Okay, so the total area of sidewalk is the area of the squares 4 times the area of the squares at the corner. Okay, and then plus, and you have a 2 type of rectangle. One is this, one is this. Okay, so it will be 2 times area of the long rectangle. Okay, and also 2 times the area of the shorter rectangle. Okay, so you can add them together. For the area for squares is 1/2 times 1/2, right? And then you have the area of the long rectangle is a 4 times equal to 1/2, right? Because the length is 4, the width is 1/2. Then the area of the short rectangle is 2 times 3 times 1/2. Okay, so let's add them together. The first one, 4 times 1/2 times 1/2 is 1. The second one is a 4. And the third one is 2 canceled out. It's a 3. So total is 8. Okay. That's a very natural way to do. But there's another way, good method, okay, is to use a subtraction. Okay, to use a subtraction because this side is 4, this side is 3. But if each side is 1/2, so the longer one can be 5. And this side is just 4, right? Because add the 1/2, add 1/2 at 2 ends. So the area is going to be the difference. 5 times 4, the larger area, right? It's the area of the large rectangle minus the area of the small rectangle. Okay. So then difference is going to be the area of the sidewalk around that. Okay. So that is going to be 20 over minus 12, which is still 8. So there are different ways you can get different answers. You can get the same answer, not different. Different ways leads to the same answer. All right. All right, now a slightly difficult problem is a still rectangle, okay? And this side is A, that side is B. And then I have 1/2, 1/2, 1/2, 1/2. Okay, so if I know A plus B is going to be 7, okay? Like a 4 plus 3, right? But not exactly, right? Can we determine the area of the sidewalk? And they have explained to me why, if its answer is yes. Wow, that is difficult one. This is a math problem, computation problem. Okay, so well, we know that when yeah, we just did that, right? When can note, okay, when A equals 4, B equals 3, right? Then the area of the sidewalk we just computed. Right, is going to be 8. We just did it, right? And see above, right? The above computation. But is this always true or not? If we change the shape of the dimension of the inner rectangle, does it change the area? See, in mathematics, right? What is so-called a theorem? A theorem means it's true in general, even for family of family rectangles. Okay, it's not necessary to be, it's not for it's a general rule. Okay, we're trying to get for a very large class of rectangles. That's true. Okay, so this is a research problem. Then the above one is not a research problem. Just do the calculation. Okay, maybe 2 different ways. You end up with the same answer. That's okay. But then and here. You see, partially is fixed. The width of the sidewalk is always half of the feet, half feet. Okay, but that's fixed. In order to get a general theorem, even that one can be arbitrary. Then you get a very general theorem. But let's fix this 1/2. Okay, how do you find the area? Okay, so now you have to find the area in many. Let's see how to do that, right? So you use the idea, we did it, right? Use the idea, okay? Use the idea, we divide into, okay? I'm not sure we can complete fix it. So the area of the sidewalk is the area of the 4 rectangle, right? 4 squares. Let's calculate this 4 squares. So that is going to be 1/2 times 1/2, right? All right, then we want to find the area of this side, okay? This one. Okay, let's find the area of this one. This two. Okay, right? We got 2 times A times 1/2, right? Twice of that, right? Then you look at the area of this two sides. Okay, add them together. And then you get twice of B times 1/2, right? That's a B. So let's simplify it. The first one is 1, second one is A, the third one is B. Wow, great. We don't need to know is exactly for a value of A, exact value B. All we need to know is A plus B. So it's 1 plus 7. A plus B is 7, which is 8. Wow. Okay, that means the area of the sidewalk is always equal to 8. It's independent of the dimension of the inner rectangle, as long as the parameters are fixed. Is independent of the dimension, okay, of the inner rectangle, okay, as long as the perimeter is fixed. Okay, so this is where we, where mathematics is used. Okay, so that means, for example, for example, you have 2 vegetable gardens, right? We always use that example. Another one is a square, right? Okay, they have the same parameters, right? So have the same parameters, let's call it, and here 7 total, the parameter is going to be 14, right? And this one, the parameter is also 14. So the side length is 14 divided by 4, which is going to be 14 over 4, right? 14 over 4. And this will be 2. That be, no, this will be 5 and 2, right? So 5, 2, or 3 and 4, doesn't matter. Okay, 3 and 4. Let's use 3 and 4. Okay, so you have 2 gardens that both, okay, what is the difference? The area is different, okay? The area is different, and the parameter is same. That means you use the same fence, same length of fence to include that garden, okay? Right? So both you have to use a 14 feet long fence to include this rectangle garden, but the other one has larger area, okay? So you can say, what is the area, okay? So this is a 14, right? This side is 7 over 2, 7 over 2. So let's compare. The area is going to be 12, right? And this side is the area is going to be 7 over 2 times 7 over 2, 49 over 4. 49 over 4 is larger than 12. We can do estimate, right? Okay, you can estimate. Okay, you can estimate it, and let's take a look at 49 divided by 4. It's actually 12.25. Okay, so the area is large. However, if your father asks you to buy bricks to make a sidewalk around these 2 vegetable gardens, you end up with the same area. That means you need to buy some number of bricks. Okay, if the sidewalk, the width of the sidewalk is going to be 1/2 foot. Okay. Okay, so if the width of the sidewalk is going to be 1/2 foot, 1/2 feet, whatever. Okay, then then the sidewalk have the same area, okay? Have the same area we just computed, okay? And which is I think which is 8. Yeah, which is going to be 8 square units. It's independent of the dimension of the inner rectangle as long as the parameter is fixed. So this is kind of mathematics. You know, we do kind of research, right? And then you get the general theorem, right? You get the theorem is this to say, hey, the area of sidewalk is independent of the of the dimension. As long as the parameters are fixed, then you have a nice result, right? And if you're doing research, which is, you know, this is all the result, right? If you're doing something, research, it's new material, then you probably can publish a paper. So that's, I just trying to tell you, you know, yeah, maybe you are doing something, you know, doing research. When you work on, when you do the research, you look at the special examples, right? And some people can quickly summarize and get the general result. Some people probably only focus on those examples, so there's a difference. Then some people become, you know, scientists. Some people couldn't become scientists. Okay, so you needed to train yourself when you do the homework. Okay, when you do the homework, you should ask yourself, hey, this is a, you know, look at 2 examples that both have the same parameter. You know, ask you, yeah, the first problem, one side is 3, other side is 4, and I end up with the same, with the area of the sidewalk is 8. Then another one you can look at 2 and the 5, right? It's the same parameter. You know, you look at 2 and the 5, right? 2 and the 5. So the parameter is still 14. Okay, and then you look at the, then you find the sidewalk, the length of the area of sidewalk. And in this case, the area sidewalk, the area of the sidewalk is going to be 8. Okay, then you connect those 2 results. You know, 3 and 4 give you the side area of sidewalk 8. Then even change it to 2 and 5. You still get the same area of the sidewalk. Okay, you should ask yourself, is this true in general as long as I have the same parameter? Then if you think about this, then you're able to get the general result. Okay, okay, this is the width of the sidewalk is always 1/2. Okay, okay, then you probably get the above theorem we did. You know, this is yeah, it's independent of the dimension of the inner rectangles, as long as the parameter is fixed. Okay, so just being alert and pay attention to what you see. So when you see something, usually it's a special case, special examples. All right, then we continue. Okay, then we continue. Now, do you remember what is a parallelogram? Okay, parallelogram means you have 2 lines of parallel, right? Okay, how can we find the area of the parallelogram? Okay, how do we do that? If this side is A, this side is B, I cannot say A times B, so the area is not going to be A times B. Now that's become a research project, right? Again, and how do we do that? Okay, so what kind of information we need to in order to tell the area of this parallelogram? Okay, so the idea is simple. You can cut it. Okay, this corner. Okay, and then you move this corner, this triangle here. Okay, and you move it to here. You put it here. Right, so you make it, after you move this triangle, you get a rectangle. So this rectangle, okay, has the same area as this parallelogram. So these 2, yeah, they have the same If this is A, this is A. Those two have the same area. They have the same area, okay? This is a, okay, they have the same area. But for the rectangle, we know how to find the area. So you need to know this side. So that's why for the area of the parallelogram, and this should be A times H, not A times B. Okay? A times H gives you the area of the parallelogram. A times H is actually the area of the rectangle, and we obtain from the parallelogram by cut one triangles. Okay? All right, so let's do this problem. Okay, let's take a look at the problem here. Okay, we have a parallelogram. Okay, and this parallelogram, it's going to be in the following shape. Okay, if this side is a a 2, other side is 2, okay? And this side is also, okay. I'm not going to, yeah. Now this side is 2, okay? So that's a picture, you know, this cannot be 2, okay? This could be 3, it doesn't matter, okay? So we don't want to give information here. So the area, okay? This is a parallelogram, okay? And then the area is going to be just 2 times 2, which is 4, okay? And it's really independent how that's you know, how big of the parallelogram, you know, you can put it here, okay? Think about that. This is a parallelogram, and the height here is 2. So what I'm going to join is I'm joining this parallelogram, okay? So this parallelogram has the same area as the one above, okay? Okay, so this is a parallelogram. Okay, this is a parallelogram. So this side is 2, and the height is 2. So imagine, you know, this getting longer and longer. If you move this 2, if you move the top one all the way to the right hand side, and this area still equals 2 times 2, okay? But just it's getting narrower and narrower when the other side is going away from, okay, getting further away. It's making this one narrow and narrow. So the area still equal 2 times 2. Okay, please, Eric, please don't type nonsense here in the chat window, okay? Pay attention, okay? All right, I'm going to ask you do the following problems. Okay, I have a picture here. Okay, I have first of all, I have a square, okay? Then I have a diagonal. This is square, right? Okay, so it's A and A. Then I just draw this. I have another square. Okay, and I draw another diagonal, okay? So my question is, there's 2 squares here, right? Yeah, this is A, that's A, okay? 2 squares, okay? Square and square, okay? What is the area of the shaded region? Right? Okay, so Alex, your brain is not shut down, okay? You should figure out this one, okay? What is the area of the shaded region? Okay. Right. So you can view this problem in two different ways. This can be the, consists of two triangles, right? So its area, it can consider two triangles, and those two triangles form a rectangle, okay? Form a rectangle, so form a square. So actually, this is just the area of the square. So A times A, okay? But this is also a parallelogram. The height of the parallelogram is A. The length of the base is B. Okay, that's easy, right, to see. Okay. Now, if I put the three squares, okay, then I connect this. Okay, what is the area of shaded region? Okay. Yeah, what is the area of the shaded region? This is a parallelogram, right? So this side is A, okay, A. Okay, what is the area of the shaded region? And first of all, the shaded region is going to be parallelogram, right? It's parallelogram. If you see this parallelogram, maybe it's easy to figure out. Okay, it's still Eric. Is your brain shut down right now? Okay, not yet. Okay, no, good. So this is a parallelogram. Okay, so the area is going to be A times A. Otherwise, height. So that's just A squared. Okay, it's easy. Okay, so now it's not an easy problem. Okay, so I have a square. This is actually in a park, for example, a square, right? It's a 16. It's a square. Okay. All right. I'm going to make a diagonal. Okay, this is one, this one, this one, this one. What I'm trying to do is I draw, people always cross this lawn, so why not build a walkway here, and also here. Okay, so this area, this is okay. So now this becomes a green area. This still is a lawn. Okay, so we keep it. Okay. Okay, in the middle we can pick Walker. Okay, so this is a picture. Okay, and total is going to be 16, but this will be 1. That will be 1, right? And here's 1. Here's 1. Okay, so it's clear the picture, right? So my question is, what is area, the total area of the remain is a lawn? Okay, and after we make two roads cross to each other. Okay. Yeah. So what is the area of this? Okay, my first question. The second question is, maybe I will ask you what is x also. Okay, can we measure the x this side? Okay. Anyone can figure out the total area of the lawn. Okay. Okay, after you make two roads across each other, before you make the roads, right, cross each other, that will be 16 times 16 square feet. Okay. Now you have 4 identical triangles, but we haven't studied triangle yet. No, so many people don't know. All right, there are two different ways to solve the problem. If you find the areas that are a triangle, maybe you can solve it. But those four triangles are identical, right? So think about that. This kind of a piece. This is kind of a puzzle. If I in the space, if I put all together those four triangles, do you get a square? Do you get a square? Right? Answer is yes. Okay, you get square. What is the edge length of the square? If you move all those four triangles close up, okay, without gap, you get a square. But that square, each side, is going to be 16 minus 2, right, which is 14. That's also 16 minus 2, which is 14. Okay, so the answer is the area is going to be 14 times 14. Okay, it's 196 square feet. That's easy, you know, right? Yeah, so those four triangles can slide together to form a square. That's easy, but if I show to you, I'm not sure you can figure it out. But we still have a question left. Okay, look at this triangle, right? This side is 14. What is the other side? Okay. Remember, right? Remember, this is actually a square. If it's four triangles, make a square, right? So this is a square. It's a square. Okay. So the length of the diagonal, you know, if this is a D, right? D equals square root 2x. We already gave you a formula, right? D equals square root 2x. So I have a 14 here. I have a square root 2x. How can I get x? Okay, I get x is 14 over square root 2. Okay, 14 over square root 2 is going to be 14 square root 2, and square root 2, square root 2, and you multiply that, it's going to be denominator is 2, so it's a 7 square root 2. Okay, it's not 7, it's a 7 times square root 2. It's a 7 times square root 2. Okay, this is a little bit difficult, and you know, our next topic will be about the triangles and Pythagorean theory. Okay, so this one it's not the integer actually. This is a irrational number. This side of x is going to be 7 square root 2. Okay, 7 square root 2. Okay, and the total is going to be 14. The diagonal of the smaller, you know, squares. Okay. So anyway, we go back to this problem. You will see that sometimes you cannot solve the problem directly. Sometimes you use a subtraction, but sometimes when you look at this picture, you have to move around the triangles and put together. If you make a perfect rectangle or squares, then use that one to find the area. Okay. So if you give enough time, you know, don't just give up. When you see a problem and they look at, oh, that's difficult, give up. You can move to the next problem, but you still have to find the time to come back to trying to solve it. Okay. Okay. So let's stop here, and I wish you have a good weekend.